Boy, that last one was a long one. Section 12, lesson 4, part 4. This is part 5. We're going to continue that adventure of finding the factorization of that polynomial. So we'll zip ahead. We'll see where we are. Of course, it turned off. So we're trying to factor this expression. Okay, we come up with this using the rational root theorem. We come up with these possibilities, and we've generated this list. There is a one there, and it's all plus or minus. Okay, we graphed it. We had to adjust the windows to get this, and we look at it and we say, okay, it looks like right here that looks like a -4 may be a possibility. 1/2. Oh, can't be 1/2. 1/2 is not on our list. -4 is, remember these are all plus or minus. 1/2 is not, so it can't be 1/2. If that in that region, that must be a 1/3, but we'd have to verify. Maybe it's like a 0.32 or something, and it's an irrational number. This is, let's see, that looks like it could be a 2. We could try either -4 or 1/3 or 2. Which one you want to try? I think I'm going to try the -4. I'll do synthetic division with x plus 4. Right? Because that would make -4 the 0. So here you go. I've rewritten the list of possibilities. I've checked my calculator. It appears to be those may be the x-intercepts. So my best guess for the factorization is that. The graph doesn't prove anything. We have to do synthetic division to demonstrate anything. So here I've chosen the -4 or x plus 4 as a possible factor. So go ahead, complete that synthetic division. And yes, -4 works. So x plus 4 is a factor. So I can rewrite this as this is my polynomial, or this is my function. I guess I didn't name it p of x. Let's name it p of x. So that is my polynomial. I could factor this, but I'm looking at saying, it could, maybe it's tougher. I could say, geez, if I know that, or if I suspect that these guys are factors, then maybe I could continue. I'm gonna use a different color, but let's check out what I can do here. Hang on a second. So I'm gonna be really lazy. I don't even have to rewrite this last row. I can say, well, if I suspect that x minus 2 is another factor, I can say, okay, I'm going to put my 2, and take the opposite of that, x minus a is, and I want to use a in that little house. So I'll put that 2, and I'm using a different color so you can see, and I'm going to continue to do synthetic division right here. I've written the multiplication here to help keep myself straight, and then I'll bring down the 3, multiply, add, multiply, and check it out. So I can say, okay, I'll bring down my x plus 4, right? And now I was factoring this using synthetic division as x minus 2, and what am I left with? 3x minus 1. So now we have completely factored the polynomial. I didn't jumpstart you at all, or actually, I didn't tell you anything except the rational root theorem. We used the rational root theorem in our calculator, and we were able to factor this cubic. Here's another one. Let's say you want to factor this. Notice it's a cubic. It's not a quadratic. Let's say you want to factor it. So you're going to have to insert a 0x squared in there. So use the rational root theorem to find the possible rational roots. It's the first thing here. Check on your calculator to see what are realistic possible rational roots, and then do synthetic division or long division to test. I'll check in with you at different points along the way. Here's the setup. Those are the possible rational roots. We checked our calculator. We got the set of realistic possibilities. Now we're going to do synthetic division. It doesn't matter which one you start with, whichever one you like better. I chose the -2 to see if -2 was indeed an x-intercept, so x plus 2 would be a factor. And then I wrote the multiplication statement, and I saw, wow, that guy is factorable. I could just immediately factor that. It was easy to factor. I could have come over here and continued synthetic division. But you can see in the graph, that looks like it's a 3, doesn't it? And that looks like a -1, and that looks like a -2. So you can see how this seems to fit. Here's another for your factoring pleasure. Go see how this goes for you. Factor the polynomial completely. Notice I give you no hints, no framework. Go for this one, see if you can do it. Here's what I got. Totally factorable. Actually, to help me, I used this graph where it appears that, let's see, I've got -3. It looks like a -3 and a -1 and a +2. So those are the values I could have tried. I tried the -3. I could have tried the -1 or the 2, and they would have worked as well. But notice we were able to factor that cubic. Here's another. You've got a 6 for a leading coefficient. So there's going to be a lot more possibilities, but you'll find it's actually not quite so bad. So go ahead, try to do the same one completely. Use your rational root theorem, use your graph. Factor the polynomial completely. Does that work for you? Okay, now notice when you listed these, it wasn't quite as many as you thought, because things like 9/3, that's equal to 3, and you've already got that value there. So there were fewer items to list than perhaps you'd thought. So like 9/6, that's equal to 3/2, and you already had that here earlier. So you find that kind of thing happens. Here's my best guess. I found that this was just something close to 0. It was either a 1/6 or a 1/9. 1/9 is not a possibility. A 1/6 or a 1/3 maybe, but it was closer to 0, so I may have been able to go there and say, well, okay, maybe it's 1/6, and it did end up being 1/6 when I completed the synthetic division. Then notice you get a quadratic. You can always factor that in the traditional ways. I thought, geez, it's just going to be quicker to do synthetic division because I kind of knew that, or I was guessing that 3 would fit there as well. So now let's look at one other thing that might happen. If I'm looking at a polynomial like this, and you have your last term to be 700, you could start listing all those, and you'd say, oh my God, you're kidding me. I have to list all those factors of 700, and there's lots of them. At some point, you might say, no, I don't have to list them. You graph it and then look at those values and say, are those values factors of 700? Would they fit the rational root theorem? So you don't always have to list those possibilities. Just graph it and then see, gee, is it a possibility by the rational root theorem? So then try to do this one and complete this factoring. That wasn't so bad. If you'd increased your x windows a little bit, you might have seen that +10 is a 0 or an x-intercept, so x minus 10 was a possibility. We didn't even need to increase our size of windows. Once we have a couple, we could keep going. We really only use 2. It's a 4th degree. Notice a 4th degree, and there's 4 x-intercepts. 4 factors. 4 what do we call linear factors, because there's no squared. Those are the first power. So we call these linear. These are linear factors. This is not a linear factor. These are 4 linear factors. I'm sure you've noticed I've had the answers, the factorization down below. So you can see something very different is happening when you've got a factor that includes a square root of 6. What is that? -1. Wow, this looks like it's really funky. What's going on here? Let's actually start in the same way, and you'll see that it's actually not that big a jump. But let's start by using the rational root theorem to find out what the possible zeros are. Number 1. Number 2, graph it. Do synthetic division to pull out those factors and see what you're left with. So you list your possible rational roots and then you graph it, and you see 2 of them end up crossing, the curve ends up crossing between 2 values. So and all these are integers. So these first 2, the 2 in the farther left, are not going to be rational. Let's see what they're going to be. Well, we'll see what that is at the end, but it looks like we might have that value at the end. So it looks like there's a 3, or x minus 3 could be a factor. So do synthetic division to check that out. Here's the next step. And you get this. That is prime. You could try to factor the heck out of it, and you're not going to get anywhere. So how would you solve if you had a quadratic equation? 0 equals x squared plus 2x minus 5. You'd use the quadratic formula. Let's see what happens with the quadratic formula. So I use the quadratic equation to solve for this, and I get two values, -1 plus the square root of 6 and -1 minus the square root of 6. That's what you get after you simplify this. So you may have observed that the factor here was always x minus the x-intercept, isn't it? So let's do that. This is x minus the x-intercept. Now if I take x minus the x-intercept, check it out, that's this one. And then x minus the x-intercept. And yes, I know that's not in fully factored form, but it lets you see exactly what's going on. So x minus the intercept, and notice it's irrational. And the only way to do that is the quadratic formula. So your homework is in the pre-cal text listed below, but of course I might tweak it.